All right, stuff out. Example 2. I believe it's 2. Did we finish that one? I'm pretty sure we did the top one. I don't know if we did the bottom ones.
He was close this morning. Yeah, very close.
That was actually probably my bad. I asked him to grab this nectar that never arrived.
We have or have not? Oh, okay.
Oh, well, I guess I did the video, so I guess
Okay. So I know we did it in our other class. We did not get to it in here. Here we go. All right. The short version of it is, if I tried to take, if I tried to do that, could I just do that instead?
No.
If you were,
You need place values.
if you were working, 2 weeks later you get your paycheck, you were expecting $302 and it says 32. Is that okay? No. You need a 0 as a placeholder, right? So we need, we're going to say 9x cubed 0x squared minus x minus 3. And then we will divide by 3x plus 2. So remind me. It's 0x squared because I'm missing the x squared term. So I need a 0 as its placeholder. Huh. Rice stuck by back tooth. Cough. So, what do we have for a process here? What am I dividing by what? What things am I looking at when I start the division process? Okay. Leading term with leading term. 9x cubed divided by 3x is? 3x squared. And I'm going to put that over the x squared term. Good thing I got a 0 as a placeholder. That started an argument this morning. We had one student who just shoves everything over on the left side and thought that's fine. It'll affect you later. And then I take 3x squared times all this stuff. So we'll have a 9x cubed. We'll have a 6x squared. And a reminder that the book, every book I've seen likes to do this. I don't like to do that because I know that I usually screw it up when I get further down. And if you look at the next example after this, we are going to have problems where we're dividing by something much larger than just a linear factor. Okay, so I prefer change of signs. Go negative 6x squared minus x.
We're laughing because I asked him for you to my sweatshirt because I forgot at home. You brought the hanger with.
That tracks. We drop one of our terms and then we start the process over, right? Negative 6x squared divided by 3x is negative 2x. Multiply your stuff through. Negative 6x squared minus 4x. Change your signs. Getting 3x minus 3. When I go to do this last part of it, something is different. Yeah, I got plus 1. Yeah, I got 3x plus 2. I changed my signs. I think that I'm done, and then ruh-roh. And if you did watch the other video, you probably heard a very heated argument about what we do after this. So someone first hour got pretty excited about, because remember the different ways that we did long division in elementary school. You'd put a decimal and then start putting zeros after it, or you would put R -5, remainder -5. But we don't do that because just like you remember the good old days when math was nice and simple, when I would say I've got 1, 2, 3, 4, 5, 6 of those, or 7. So 7/3 could really be written as 2 and 1/3. You're like, oh, take me back. Like, can we just do that now? No. It was 1 left out of 3 because I'm dividing each of them by 3. So I can do the same thing with this. I can say minus 5 over 3x plus 2.
That makes a lot more sense than just putting remainder -5.
Right? Just like I have 1 left out of 3 because I'm dividing them into pieces of 3, I'm going to have minus 5. Now you could also, some of us just don't like that and want to put the -5 up top. That's cool too. Same difference. So, 2 things about this. A, you got to have your zeros as placeholders. Always check that. I said that I don't know how many times. I had like 7 kids screw that up this morning. They just missed a 0 as a placeholder. 2, if you ever get a remainder, you just write remainder over divisor. So, there you go. And yes, I only want you to do part A because we are going to come back to this and use that other space for something relevant for today. This just is a really, really good example, and I would like to have the answer there to work next to. Maybe you should do this. Just a thought. So first off, do we remember the steps? Divide, multiply, subtract, drop, start over. Now, when I do the change the signs thing, it's a lot easier to see up here because I'm constantly switching the colors, so you can see where you literally change the signs. Might not be as easy to catch that, whether you did it or didn't do it, on your paper when you're just jamming away in pencil. I do change the signs. you might subtract parenthesis that expression. You do you. Whatever makes the most sense to you. You're the one working there. You got to organize it in the way that makes sense for you. Okay. Are we getting the same thing? The only difference between this and where we left off on Friday is now I have that minus 2 at the end, so I'm going to tack on a minus 2 over the divisor, 2x minus 3. Easy peasy?
Yeah.
Okay. Now, some of us were already talking about this on Friday saying, wait, synthetic division, I know that. Or that was easier. Not yet.
It was.
Oh, it is. It really is. But
The one with the box.
we got to know how to do both because we're not always dividing by a linear factor. Synthetic division, as you know it, only works with a linear factor. There is synthetic division for higher order polynomials. Go ahead and Google it. It's gross. It's just this entire like box matrix of numbers and lines all over the place. It looks like, I don't know, Bender farted. Like it's just Futurama, dude. It's pretty messed up. So we need to know how to do long division because sometimes we're going to long divide by things that are way bigger. Like, what happens when I divide a quartic by a quadratic?
You get a quadratic.
Right? I'm reducing it 2 degrees. In fact, we're going to use this in later sections. That's why we got to review it now. X squared minus 2x plus 7 into 2x to the 4th minus 4x to the 3rd. Double check for any placeholders that I need. And I am not going to need all that space. So we're going to move you down. There we go. You still start with leading term divided by leading term. 2x to the 4th divided by x squared.
2x squared.
Okay. When I take 2x squared times my divisor, then I'm still going to distribute it all the way through. That's 2x to the 4th minus 4x to the 3rd plus 14x squared. I'll change my signs, or are you seeing hopefully more now why subtract the thing might end up goofing that up? Because as the terms get longer, the chance that I subtract this, add this, completely forget, and end up adding this are going to get bigger and bigger. So I prefer to change the signs. I subtract this, add this, subtract this. The first 2 terms cancel. That doesn't always happen. We just got lucky this time. Getting a negative x squared. So if I only have 1 term there, I want to drop 2 so that it still matches my divisor. 3 terms, 3 terms. Drop this, a little hot. Drop this, a little warm. And then start over. Take a negative x squared divided by x squared. Just a negative 1, where do I write it?
Under the negative 1 and a constant.
Okay, now technically, if you wanted to, technically you could put a 0x cubed here, drop 1 term, say it goes in there 0 times, drop the 11, and then go. But do you see how that's kind of a waste? So instead, I'm just going to say minus 1 here, and I'm going to not do that. We'll say negative 1 times the stuff is negative x squared positive 2x negative 7. Change your signs. Bop, bop, bop. Getting x minus 4. When I try to divide this, x divided by x squared. 1. But I now have x on denominator. The same as if I tried to take 4 divided by 9. It doesn't go in there at all. So I would need to keep going on to the next place. Well, I ran out of places. In this case, I ran out of terms. So this is my remainder. And if that's my remainder, I put remainder over divisor. Even if they get big like that. This is going to come back to us again at the end of chapter 6. We got a lot of heavy lifting to do this week with these. But we will see the long division and that. It's called partial fraction decomposition. We're going to see this again. Okay, so watch out for zeros as placeholders. Divide. If we do it right, I only see a need to do it once. 2a, what you got? Hmm. 2x cubed divided by x squared. Just a 2x. 2x times stuff. 2x cubed, 6x squared, minus 8x. Change your signs. Change the signs. And get a negative x squared, a positive x. I got 3 terms over here. I want 3 terms down here. Drop it. A little warm. Go one more time. Say negative x squared divided by x squared is negative uno. Negative x squared minus 3x plus 4. Change your signs and it's still not quite enough. I'm going to end up with a remainder. 4x plus 2. We've spent so much time on factoring that some of us might see that and try to immediately divide it by 2. Or factor a 2 out of it, or something like that. No. 4x plus 2. Just That's my remainder. So I'll get a 4x plus 2 over x squared plus 3x minus 4. Now, if for some reason that reduced that entire thing, you could. But if you could reduce that, you could have reduced the whole works before starting. Okay? All right. I also want to leave that space because y'all see that this is factorable. X plus 4x minus 1. That means I could theoretically do double synthetic division, but they result in remainders. So if they result in remainders, that means you're going to do synthetic division into a remainder. Getting a remainder within a remainder is a compound fraction. And I know y'all don't like fractions. So I do want to leave this space because if I remember, we can come back to this one when we do our next section. Yeah, that was collectively what we were finding first hour too, even as we started ramping this up and doing synthetic. Kids know what they're doing. It's just basic arithmetic errors. Y'all, I've been up since a little before 4 again, which means first hour got their brownies off me. Okay.
We're close to.
They were 2 off at the beginning of class. They got me. One was a technicality though. Like I put the question mark next to it. And then I erased the question mark and I fixed the thing, but I fixed the thing writing the wrong number, so then they got me because the question mark wasn't there anymore. It's like they rules lawyered me into the last point.
Well, we might as well get the 2 because you can just bring 2 class. This is full of brownies. No.
No, we only got 1 lid for the big tray.
Oh.
So, are we okay with this so far? Long division, yay. I don't care whether you like it. You can do it? Okay. So, if I keep everything lined up like this, notice that x cubeds, x squareds, x's, and constants are always in the same lines. Always in the same columns. If they're always organized like that, well, some famous dead math person comes along and says, what if I just got rid of all of that alphabet soup? Would it still work if I just kept them lined up? And it does. And since your pattern is always divide, multiply, subtract, drop, start over, they took that pattern and made it into an algorithm where, what if I just did only coefficients? Well, they're lined up, so everything's still where it needs to be. I'm just going to get rid of all the extra work. And they notice it doesn't quite work when I keep, if this was dividing by x minus 3, but since I always subtracted the thing, what if I negate this, which is the same as finding the 0 of your divisor? And you should remember something along the lines of drop the first term, multiply, add, start over. Multiply these two, add, start over. Multiply these two, add. Multiply and add, and multiply and add, and multiply and add. And that is synthetic division, where I cut out all of the extra garbage, and because I have organized it in such a way, I'm able to do these way faster. But I know that none of you had me for Algebra 2, so when we do these, you might get a little weirded out by the way that I draw my bar. My bar is set up for when we have to do these in a chain for long polynomials. Do you remember getting like a quintic, and then you do synthetic, now it's a quartic. You do synthetic, now it's a cubic. You do synthetic, now it's a quadratic. Oh, hey, I know how to deal with quadratics. Dump it into the formula. To put them in the chain like that, the way that we usually did that was Depends on your jam, depends on which textbook you were looking at. Only your coefficients get written down. All of your coefficients. All of your coefficients. Who's missing? I don't have x cubed. So you better put 2, 0, -5, 5, -2, versus 2, 0, -5, 5, -2. It's always the 0 of your divisor. So I say x plus 2 equal to 0, x equals -2. I put that -2 out here. I'm just showing you the two different ways that it's written. The way a lot of textbooks will set this up is they'll put this little L bracket here and then just a line going down to their next line of work. The way that I was taught and the way that I really like for organizational purposes when we have to do multiple of these in a row is I just take my division sign and flip it. That's it. You do you, okay? I'm going to write it like this. I'm just telling you they're the same thing. Stage 1 is always drop it, and then you multiply and add and multiply and add and multiply and add and multiply and add. But you have to drop that first term to get started. It's kind of like you can play the game, but you got to put the quarter in the machine to get going. So I take -2 by 2 is -4, add them. -2 by -4 is 8, add them. -2 by 3 is -6, add them. -2 by -1 is 2, add them. Now, whether I'm doing that here or here, it's the same thing. Okay? It's just where you put your bars and brackets. So, okay, Max already got it with the last one we were talking about. If I have a degree 4 and I'm dividing by a degree 1, what is my answer? Cubic. So I start writing x cubed here, -4x squared here, plus 3x minus 1. What is that 0 at the end? Remainder. This is my remainder. If it's my remainder and my remainder is 0, that means I won't have a partial fraction at the end. It also means that this is a factor. If this is a factor, then I could say something like f of x is this times x plus 2. Right? Now, I don't have to write that part. I'm just showing you, hey, look, this is a factor. Because at the end, I hit 0. Now, before I go do B, I found out this morning, no one who was in the new textbook, the purple book for Algebra 2, knew what I was talking about. So I'm betting none of you have seen this before. I want to back up to example 2a. And we had 8x cubed minus 18x squared plus x minus 20 over 2x minus 3 is 4x squared, 8x cubed minus... Okay, so you already have that on your paper. I want you to do synthetic division next to this. But what is my dividing term? right? So I'm going to need 3 halves here with 8, negative 18, 21, negative 20. We know how synthetic division is supposed to work. I want you to do it and see what happens. Remember, drop the first term, multiply and add, and multiply and add, and multiply and add. You do not need a calculator to do this fraction. Divide it by 2, then multiply by 3. Do it in pieces. Or multiply by 3, then divide by 2. Okay? Don't take it times 3 halves all in one shot. Take smaller bites. My 3-year-old got brain freeze for the first time last week. Just like this giant honks of ice cream, and he fell back on the couch just screaming in his head. I felt bad, but at the same time, get wrecked. He was a lot more cautious about eating it afterwards. Oh, it does.
Why do I not remember where we are? No, you get a remainder of reminder's positive.
Remainder should still be negative 2.
Where's 2a? I got 0.25. Oh, yeah. Oh, here it is.
Multiply and add, and multiply and add, and multiply and add. Drop the first term to get started. Half of 8 is 4. 4 by 3 is 12. Add them together. Get negative 6. Half of negative 6 is negative 3. Times 3 is negative 9. Add them together. Get 12. Notice how I'm getting these same numbers. Okay? Half of 12 is 6. 6 by 3 is 18. Negative 2. But last I checked, 8x squared minus 6x plus 12 was not 4x squared minus 3x plus 6. But how are they related?
Divided by 2.
Okay. And it comes down to some nuance, and this is what I don't think it's even an example in the new curriculum where you have a value besides 1 in front of x. I don't think you've ever seen that. When I did this, right here at this stage, I divided by 2, right? If I divided by 2, I am no longer dividing this by 2x minus 3. I'm dividing by 2x minus 3 halves. Because didn't I put a 3 halves there? This is half as big as it should have been. Maybe you think of it like, whoa, touch the board. Maybe you think about it like you factored out a 2. So if I'm dividing by something half as big as it should be, that means my answer is twice as big as it should be. Very simple fix. If I have 2 for a denominator here, I need to divide all this by 2. I'm not going to divide my remainder because what do I always do with my remainder? It's going to be over 2x minus 3 anyway. So it is still 4x squared minus 3x plus 6, and then minus 2 over 2x minus 3. See, the 2 is already there. So I don't divide that part by 2 because it's the remainder. It's going to be put over the divisor anyway. But this little trick is something that we probably didn't see in Algebra 2. But it's not a difficult trick at all. Now go back to the example we're actually on. I just wanted to come back here because we already knew what the answer was and we could compare them. All right. So now go to part B Do I need any zeros as placeholders? Write out your coefficients. 10 minus 13, 5, negative 14. I am 2x minus 3 equal to 0, 2x equals 3, x equals 3 halves. Again, drop the first term to get us started, and don't try to do 3 halves, do it in pieces. Half of 10 is 5, times 3 is 15. Add them together. Half of 2 is 1, 1 by 3 is 3. Add them together. Half of 8 is 4, 4 by 3 is 12. Add them together. And that's the trick. If I divided this by 2, that means that my coefficient answers are twice as big as they should have been. So I'm going to cross that out real quick and call it 5, 1, and 8. And 4.
Brownie, haha.
Basic arithmetic. Can't do it. And then throw all your variables in there. If I take a cubic and divide it by a linear, I should be at x squared plus, it's like a xx, plus 1x plus 4, and I don't divide this by 2 because I'm about to put it over 2x minus 3 anyway. Okay? Now, there is another way to do this. I know y'all ain't going to like it. I'm going to show it to you anyway. And then you decide which way you want to do these problems. Ahem. I divided by 2 here. It is not that bad.
No way.
3 halves by 5 is 15 halves. Add them together, I get 2 halves, which is 1. 3 halves by 1 is 3 halves. Add them together, I get 8 halves, which is 4. 3 halves by 4 is 6. Put them together is negative 1. Oh, wait. I divided all of my starting coefficients by 2. But I'm not supposed to divide my remainder by 2. So now I need to double this. What was that? Yeah, squared x plus 4. Now I'll double this part.
It's a minus.
Over 2x minus 3.
It's a minus.
What?
The x is a minus x.
No, it's not.
Wait. No, it's not. It's a minus. Jace is trying to catch him slipping. It's not a minus 4. What?
Okay.
Oh my god.
So, and that legitimately, that is the issue that we see with these. It's not the process. It's oops, basic arithmetic. Okay? So, I'm guessing y'all want the first option instead of this option. They do both work, but given the choice to not work with fractions, most kids will choose that. Go, both of them. Well, because one does have a leading coefficient of 1, the other doesn't. So we need both. I never catch anything. I'm impressed by myself.
I hate when they get. Then I think I'm wrong. Did it get really big, Emma? Drop to 132. If you divide this Jean-Pierre
That's 120, 132, 140. And 6. Drop. So as long as we can multiply and add correctly, which occasionally is a legitimate question, hopefully we get here, but then what do we do with them? What does it mean? First one, do I have to alter my answer in any way, shape, or form? Okay, so I go straight to, this is a cubic divided by linear, so it starts off as x squared, then descending order, 15x plus 44. I have a 140 at the end, so I write 140 over x minus 3. Do I have to alter my answer on 4b in any way, shape, or form? Divided by 3, not negative 3, because, see how I put a negative 1/3 here? That means I'm using x minus a negative 1/3 as my factor, which is x plus 3, or sorry, 1/3. It's like factoring a 3 out of that 3x plus 1. So the negative is already taken care of in the fact that it's 0 of. If this is divided by 3, these get divided by 3. That's 2, 3, negative 6, negative 2. It was a quartic divided by a linear. So I start with x cubed, then x squared, then x, then constant. This guy doesn't get divided because at the very, very, very end, I'm going to have a 9 over 3x plus 1. Cool. All right. Now, you notice as we've been doing these, you all wanted to avoid the I'm going to start with fractions problem. Could you do this with fractions? Can you multiply and add with fractions? All right. Too bad. Because, here we go. We're going to alter this. Variables are just variables. You can do what you want. I'm going to turn that into a 4y plus 3. Go.
That's a you guys.
Who?
3/4 of 1.
You can do it.
3/4 of 1.
I know you don't want to do it, but you can do it.
That was all relevant because either way it's just going to be 0.
14.
And 6.
You get a 964.
There you go. 9/64. Is it a negative? Oh no, it's just 9. So negative
You
10.
did that one in your head. Wow.
Well, it's 10 times 64.
640.
640
Wait, isn't it?
minus 9. Or negative 640 plus 9, but same thing.
When did I type it?
Wait, what?
Isn't it?
If it's 640, when you subtract 9 from 640?
Negative 640 plus 9.
Are you sure? Because my calculator.
631.
Yeah.
Ah, it's another brownie point.
I was like, that's not.
Boom. There we go.
I think this is the one that I had the question mark on, and then erased, and then put like an 8 here instead. First hour.
That's brownies.
Crap.
Not Friday.
Well, you're not getting them tomorrow because first hour did. So,
Well, Friday's nice
Thursday.
because it's brownies.
there we go. Okay.
Then you have to divide it by 4.
Right. So since I divided by 4 here, then I divide by 4 here, and here, and here, and not here. I took a cubic divided by linear, so this is x squared plus this much x minus this much constant. Yes, they're wise. However, if you're going to call that a brownie point, I'm going to call the same thing when I see you do that on the test. Yes, they are y squareds and y's. The last one. How do I write that?
Minus 6. Whoa, that's good.
631 over 64 over 4y plus 3, which is a compound fraction.
I do not think that's 3 over 64.
Dividing by 4 is the same as multiplying by 1/4. It's a compound fraction. I should not leave my answer with a compound fraction. Luckily, dividing by fractions is easy as pie. Flip second multiply. I'm taking this times a 1 over 4y plus 3. Dividing by that is the same as multiplying by its reciprocal. Multiplying by its reciprocal means I now must distribute 64 in there. Getting final statement. Y squared over 4 plus y over 16 minus 3 over 64 minus 631 over 642 4256 y plus 192. Blech.
Can you just put the can you do 1/4 then put the y straight next to it?
Yeah. I'm writing both so you see that both are viable ways to write your answer. Oof.
What's oof?
Oof.
Oh, what?
Fractions and stuff.
What did you just do though? Every time I drift off for a minute, something weird happens. Oh my.
I distributed 64. Dividing by thing is the same as multiplying by 1 over thing. Yes?
Is it okay if I wrote 1/4 y squared?
Yeah. I have both there to show you that both are valid ways to write your answer.
Why do we have to divide by 4?
Because
He doesn't want
you
to cross
didn't
out fractions.
you didn't divide by 4y plus 3. You divided by y plus 3/4. So if you took a 4 out of there, you should also take a 4 out of here because this is now 4 times too large. Hold on, tell her no. She's gonna laugh at me or be really upset. One of the two.
2 plates of granite. My bad. Basic arithmetic sucks.
So, ooh, back up to this. Yeah, back up to that. And give me that look, Johnny. This like I just smelled a fart. What is this crap? Kind of like no. Yes, we're going backwards because it leads into what is forwards. I would like you to, if you would, quick. What is the function of negative 1/3 for this? Everywhere there's an x, I'm going to put a negative 1/3. Okay. So that's 6 by negative 1/3 to the 4th plus 11. Start typing. Negative 1/3 to the 3rd minus 15, negative 1/3 squared minus 12, negative 1/3 plus 7. Right?
Huh?
That was very loud.
Didn't we set this equal to 0? I'm curious what the function of negative 1/3 is. Just like over here, I'm curious what the function of 3 is.
Let's see your mental math.
Oh, so we're just doing the function of
Mhm.
right now. We're not, it has nothing to do with dividing or anything. Right? We're just doing this for
I bet it
Sugar.
equals what the right answer was or something. I'm just thinking out loud.
We're doing this for shiggles or
Oh, there's a reason.
not shiggles?
4, 3, 4, 7, 5, 12, 15, 15, 3, 45, 45. 5, 1, 3.
What?
That was quick.
Oh.
That's my guess.
Great
Well,
guess.
great
Really
guess.
good guess.
Press the buttons. Make sure.
What? So the remainder is the function.
Okay. That exact epiphany there. Many moons ago, famous dead math person says, "What? Wait, if this Like, if this goes here and then that goes, wait, does that mean? And then just started testing it.
Yeah, I got one.
And sure enough, your remainder at the end of synthetic division is the same as if you had plugged in that value. Because, do we remember that if this is a factor, then this is a 0.
Oh.
If this is a 0, then this is a x-intercept. If this is an x-intercept, then this is a solution. It's a solution because I'm going to set the thing equal to 0. And what is x that gets me a 0 for y? And they start putting those pieces together, and it says, wait a second, I have something now with that remainder, and it's called a remainder theorem. The remainder theorem, the whole point of this lesson is that if I do synthetic division, whatever the remainder is the same as the function value. That's what it says right here. The remainder is function of c. This is also called, if you may have seen it called this in a different textbook or not, synthetic substitution. Where instead of me plugging the value in, I can do the synthetic division, which might be faster. So, example is number of tickets sold at a high school football game modeled by this polynomial. Apparently, the math teacher is taking tickets at this game. Legitimately, when we're bored, we start doing this kind of crap. Yeah, I usually know the exact rate and mileage and time of when I'm going to get somewhere when I'm driving long distance because I get bored and start doing the ratios in my head. Like, when you go to Safeway or Walmart, they have the unit price on something where it's, so many cents per ounce of this cereal. I was the guy who was standing in the aisle doing that in my head before they started putting that on labels. That's only been the last 10 years or so that's been around. It used to be just me sitting there staring, like the gif with the guy from Hangover and all the numbers floating around him. And then I'd grab this box because the unit price was lower. Okay? Yeah. People would walk kind of by me like that in the aisles. So I could, T of thing is thing cubed minus 12 thing squared plus 48 thing plus 74. And they said this particular formula is x is the number of games played. T of x is going to give me my tickets. What happens on the 12th game? So I shove a 12 in there. Do you really want to do 12 cubed? Do you really want to do 48 by 12? Do you want to type all that stuff in a calculator? Or could we instead say 1, negative 12, 48, 74, go synthetic division on it with that particular 12. I don't change a sign. I just synthetically substitute in a 12 and get 12 by 1 is 12. Add them together, I get a 0. 12 by 0 is 0. 48 plus 0 is still 48. 12 by 48 is 144 by 4 is 596. 76. Add them together. 0, 1, 0, 5, 6. That remainder at the end should be the same as it is here, but I did mental math, and as we've just proven, I'm not exactly the greatest at that at the moment. So, double check it. Like, if I plugged that in for t everywhere, or x everywhere in this equation, I would get the same thing. So, do it again with 13. part B, or the guide and practice part of it, is you go do this with, find the 13th game. How many will we have? That's 1, 13, 13, 1. 13, 1, 13 there, 61. 61, 13, 6. 10, 3, 61, 6. 600, 6, 10. So 180, 6, 90. What's that, 693? 7, and then 74.
Oops.
8,
What's 61?
867 or 786? 860, okay.
What did I do? What's 61 times 13? 867. 1 times
693,
So what I
right?
Oh yeah.
1 times 13.
6,948.
Whoa.
693. And then 6
Plus 74.
13 is 7. 7. 1. 6.
You should have seen my mental math before, children.
What do you mean?
Remember 3 variable systems?
Yeah.
I do that in my head, and while kids are writing the problem down, I write the answer.
767.
8.
I can't do that anymore.
867.
When's the last time you got 7 hours of sleep?
That's funny.
6 hours.
Total, that happens about once a month.
I slept 8 hours last night.
Shut up, show off.
I slept like that.
So,
What?
I slept like
I like sleeping.
super tired.
I ain't gonna lie.
okay, skip ahead to example 6. This also gets us our factor theorem. Factor theorem says, if I divide by something that is a factor, what should I get as a remainder?
0.
Right? If something's a factor, I should get 0. Kind of like if I take 30, y'all remember factor trees? 2 and 10, 3 and 10, I can do math. 2 and 5, so 30 is 3 by 2 by 5. That means I could take 30 and divide it by 2. There's still a 3 and a 5 left over. I could take 30 and divide it by 3. There's still a 2 and a 5 left over. I could take 30 divided by 5. There's still a 2 and a 3 left over. Right? And in every one of those cases, when I divided by 2, by 3, and by 5, I always got a remainder of 0. The same thing works for polynomials. If I do division, synthetically or longhand, and it is a factor, I should get what at the end? 0. This is how I test. This is what the factor theorem is. If something is a factor, I should be able to do synthetic division and get a 0 at the end. So they ask, are these things factors of this polynomial? I test it by doing synthetic division. So step 1, 4, 21, 25, negative 5, 3.
You like 21?
Like that was a full Frank song that you sung today, like out of nowhere.
No, it was not. She said 21. I said, can you do something? Rich flex for me.
I'm going to do synthetic division with a 1. 1 by 4 is 4, add them together. 25 by 1 is 25, add them together. Not looking good. 1 by 50 is 50, add them together. 45 by 1.
I didn't get as huge as I thought it would.
I did not get 0 as a remainder.
Multiplying by 1.
So that means, just like if I were to take 30 and divide it by 4, I would end up with a remainder, right? So that means 4 is not a factor of 30. Same thing here. I now know
7.5.
this is not a factor. So we'll test the other one. Now, y'all got margins and space to write. I'm just going to delete this. You okay there, bud? Okay, I'm try the next one. -3, 4, -12, 9, -18. Whoa, whoa, whoa. -27, -2, 6, 1, -3. Skadoosh. Okay. So at the end, I get a 0. If 0 is my remainder, then that means that this is a factor. And just like we were saying before, read the directions. Write a factored form. Be careful, there is a difference in articles. Where's my English people at? What is the difference between those two articles, between find a factored form and find the factored form?
One is like, yeah, one's specific, one's not.
Okay. English is important, but math is importanter. Okay. If we have 0 as a remainder, that means this is a factor. If this is a factor, then I can write this as f of x is x plus 3 times what? Just like when I was dividing 30 by all that stuff, I can rewrite it as its factors. I took a quartic, dividing it by linear. This should be a cubic. 4x cubed plus 9x squared minus 2x plus 1. When we say write it in a factored form, that means you don't have to go to the fully factored form. Fully factored form, is it F's in math instead of F's in chat? Fully factored form. If I have these two things multiplied together, they are factors, right? There you go. I got a factored form. It means I don't have to break this down into linear and irreducible quadratics. Knock it off.
He's trying to smash my foot.
We all know I would never do that. Don't write a. I'm actually not doing anything.
He actually is that.
I mean, we
say do it.
could just put Jace up there too.
Yeah, get him up there.
So, next one. Try him.
Big J, get him up there.
You up here.
He's not up there. I feel like I got up there way easier.
Not easier, dude. I knew you'd be up there on the second day of class.
You're just one of those.
You've been misunderstood by most people.
I have so many memes for this. When I go to divide, which one do I divide by first? Okay.
Which one? Where should
2, -1. Right there with B. I'm just going to show you that there's two ways to do it. Okay, 2, -1, -41, -20. And if I try -4 first, drop the first one, go -8, -9, 36, negative 5, 20. Yee. It works. Just wait for it. If I have 2, negative 1, negative 41, negative 21, what if I tried instead? What? I'm going to veto that because these two are being goblins and it's just annoying me and I can't think.
Goblin face?
2, 10, 9, 45, 4, 20. Shoot. They both worked, right?
They're both.
Here's the problem. If they both work and I want to write my factored form, then at the end of this, I need to say f of x is x plus 4, x minus 5, something. Do I know what that something is yet? But this is why I like that upside down bar. Do you remember doing chains of long or synthetic division in algebra 2? That now I can keep going with the other one. Drop 2. 5 by 2 is 10. Add them together is 1. 5 by 1 is 5. Yee. If I go in a chain and say if I've already done 5, let's try negative 4. Drop the 2, negative 8, 1, negative 4. Yee.
What? But they both worked again, so what do you... Oh, they're the same.
I'm showing you the two different ways to get there. Y'all, just like with that 30. 30 divided by 2 is 15. There's a 3 and a 5 left over. 30 divided by 3 is 10. There's a 2 and a 5 left over. 30 divided by 5 is 6. There's a 2 and a 3 left over. If I divide by one factor, the other factors are still there. So I just keep going if it works.
So basically, we're just figuring out whether or not they're a factor.
But since they're both factors, at the end of the problem, you either do this or this.
Prove it.
In both cases, didn't I find out that there's a 2x plus 1 left over? Right? I'm not going to get to that 2x plus 1 if I divide them separately.
Because you couldn't do it again.
I will show that they are both factors, but I won't get to the resultant. I won't get to that quotient of 2x plus 1 if I don't divide them in a chain like this. And that's why I use that upside down bracket, because then it just keeps narrowing down into a V. And then finally you should get a 1 at the very bottom when you divide by all the zeros, which is the remainder of this week. You remember finding all complex zeros? Whether they're rational or irrational, whether they're real or imaginary, gotta find them all. Okay? So, y'all, I don't know how. Maybe it's just because of the sleep deprivation. You have finished 14 minutes ahead of first hour. That's where they left off. That's how bad first hour went today, and I think it's just because I can't think straight. Okay?
And our period is better.
Tired. So your choice. Do you want to keep going?
Might as well.
Or you want to just be done there?
Let's just keep going.
Do we have homework?
Oh, yeah.
Okay, so do we stop?
Will you get our assignment?
Stop and I'll get the assignment ready.
Wait, if we keep going, would we stop tomorrow too? Like early?
Yeah.
Probably not. We're Let's be real.
I say we make first hour like crank it up to the next level.
I say stop.
Keep going.
Mike doesn't even pay attention anymore.
Old school, heads up, 7 up, close your eyes.
Chase, you better put your thumb.
Okay, no peeking, Max. Stop now, thumbs up. Keep going, thumbs down. All appendages down, eyes up.
Keep going.
The village has voted to stop here. So,